Right now, something 13.8 billion years old is touching your skin. Not a metaphor, not poetry. The oldest light in the universe, the literal afterglow of the Big Bang, is physically arriving at your body at this exact moment and has been your entire life. You just can't see it. Tonight we're going to find out why, and then we're going to do something strange. We're going to visit the emptiest place in the known universe, turn on every frequency at once, and discover that even there, in the darkest corner of creation, the sky is on fire. If that sounds impossible, good. Grab something warm, get comfortable, and do not leave before the void breaks everything you think you know. If you are new here, welcome to Sundown Science. Hit like, subscribe, and get comfortable. Because tonight, I am going to prove to you that the darkness you see when you look up at the sky is just a limitation of the human eye. Now, settle in and let's ease into it. Part 1. The sky is not dark. You are blind. The universe is not dark. You are. That's not an insult. It's just physics. And by the time we're done tonight, you will never look at the night sky the same way again. Not because anything up there will have changed, but because you will finally understand what you've been missing every single time you looked. Let's start where we always start. A clear night, no moon, you're somewhere far from the city. Maybe you drove out to the countryside. Maybe you hiked to a ridge. Maybe you just got lucky with the weather. You tilt your head back and you see it, a field of scattered white points against a field of perfect black stars, some of them sharp and steady, some of them shimmering at the edge of your vision, and between them, nothing. Black. The deep, quiet, enormous nothing of outer space. That image feels like truth. It feels like the universe showing you its face. And that feeling has shaped human philosophy, religion, poetry, and science for as long as we have been able to look up. The night sky feels honest. It feels complete. It feels like what's actually there. It is not. What you are actually seeing when you look at the night sky is the equivalent of a person standing in a concert hall while a full orchestra plays and hearing nothing because they're wearing one very specific type of earbud that only picks up a single instrument in a single octave. They hear one violin and they conclude, this room is silent. That's you. That's your eye. That's the biology you were handed by 4 billion years of evolution that never once needed to see in radio waves or gamma rays or microwaves, because no predator on the African savanna was going to sneak up on your ancestors in the infrared. Your eyes are exquisitely tuned for a very specific, very narrow task, detecting photons with wavelengths roughly between 380 and 700 nanometers. That is your visual window onto the universe. That is the single violin. Now here's the thing about that window. The full electromagnetic spectrum spans from radio waves, which can be hundreds of meters long from crest to crest, all the way down to gamma rays, where the wavelengths are smaller than the nucleus of an atom. We're talking a range of roughly 10 to the 24th power. And you see a slice of that, a range so narrow that if you laid the entire electromagnetic spectrum out across a football field, the portion your eyes can detect would be thinner than a single human hair. A single hair on a football field. And from that single hair, you've been building your entire model of what the universe looks like. This is not something to feel bad about. It's something to feel genuinely unsettled by. Because here's what that means in practice. Every time you've looked up at the night sky and concluded that space is mostly dark and mostly empty, you are making a judgment call based on one channel of information out of what amounts to an essentially infinite number of channels. You were tuning a radio to one specific frequency and concluding there was no other music. The darkness you see is not out there. It's in here, in the machinery of your perception. The universe, operating on every channel simultaneously, is inescapably and continuously bright. Not bright in the way your bedroom light is bright. Not bright in a way that would hurt your eyes if only your eyes could see it, but present, everywhere, at every scale, in every direction, in forms so different from what you'd call light that calling them light at all requires a mental reset. Let me give you a number and then make it real for you. Right now, as you watch this, somewhere around 411 cosmic microwave background photons are passing through every single cubic centimeter of the space your body occupies. Your body is not 1 cubic centimeter. It's roughly 62,000 cubic centimeters of volume if you're an average adult. Do the multiplication. That's about 25 million ancient photons moving through you every second. These are not new photons. These photons are approximately 13.8 billion years old. They were produced when the universe was a few 100,000 years old, when everything was so hot that matter and energy were locked together in a single screaming plasma, and they have been traveling through expanding space ever since. They are the oldest light in the universe, and they are passing through your body right now, as you sit there, as they always have, as they have been doing since before your species existed, since before the Earth existed, since before the sun existed. But you can't see them, so you called the sky dark, and that's just one layer, that's just one frequency, that's just the one oldest signal. Because alongside those microwave photons, right this second, roughly 336 cosmic background neutrinos are passing through every cubic centimeter of your body. Not your whole body, every cubic centimeter, every little unit. These are particles so weakly interacting that they can pass through a light year of solid lead without bumping into anything. They were produced 1 second after the Big Bang itself. 1 second, when the universe was so hot and so dense that even neutrinos couldn't escape without interacting. And then they did escape, and they've been flying freely ever since, filling every corner of space with a ghost-like rain that no human eye, no human skin, no human instrument built before the 21st century could ever detect. And that's still not everything. Gravitational waves, ripples in the actual fabric of space-time itself, produced by collisions between supermassive black holes, are passing through you constantly. Not occasionally, constantly. The nanograv collaboration confirmed in 2023 that there's a stochastic gravitational wave background, meaning a random, omnipresent hum of space-time distortion that never stops. You are, at this very moment, being very gently squeezed and stretched by the gravitational echoes of the most violent events in cosmic history. So let's be honest about the opening image. That quiet, dark night sky you pictured at the start, it's an illusion. A beautiful, poetic, deeply misleading illusion. The sky is not quiet. It is not dark. It is not empty. It is the single most information-dense environment you could possibly stand in, and your biology, through no fault of its own, has been hiding most of it from you your entire life. Tonight we're going to fix that. We're going to add layer by layer to that image until you can see what's actually there. We're going to visit the most extreme environment in the observable universe, a void so impossibly empty that it has become the gold standard for isolation, the benchmark for nothing, and we're going to measure what the sky looks like there. And what we're going to find is going to be one of the most quietly disturbing things you have encountered, because it is going to suggest that darkness, in any fundamental sense, does not exist. Not on Earth, not in orbit, not on the far side of the moon, not even in the emptiest known region of the observable universe. Darkness is not a feature of the cosmos. It is a feature of your eye. The sky is not dark. You are blind. And let's go find out just how blind. Part 2. The old problem that never made sense. Here's a question that should have broken physics about 400 years ago, and somehow didn't. If the universe contains an essentially infinite number of stars, distributed across an essentially infinite volume of space, then no matter which direction you look, your line of sight should eventually hit the surface of a star, which means the entire night sky should be uniformly, blindingly bright, about as bright as the surface of the sun in every direction, all at once. No dark gaps, no black background, just fire. This is called Olbers' paradox, named for the German astronomer Heinrich Olbers, who formalized it in 1823, though thinkers as far back as Johannes Kepler had been wrestling with the same question. It's one of those problems that sounds almost silly when you first hear it. Obviously the sky is dark, what's the big deal? And then becomes deeply alarming the moment you actually sit with the logic. If there are enough stars, and if the universe is old enough and big enough, the light from all of them should add up into a uniform blaze. The sky should be on fire. It isn't. Why? The answer turns out to have two parts. First, the universe is not infinitely old. It has a finite age, about 13.8 billion years, which means light from stars more than 13.8 billion light years away hasn't had time to reach us yet. There's a horizon. Second, the universe is expanding, and it's expanding in a way that stretches the wavelength of that light as it travels, shifting it toward longer wavelengths, draining energy from it, pushing it out of the visible range and into the infrared, microwave, and radio bands. So the universe is, in a sense, drowning out its own brightness by diluting it across the spectrum. But here's the subtle point the paradox leaves behind once you resolve it. The solution tells you the sky isn't bright in visible light. It says nothing about all the other channels. The expansion-shifted light doesn't disappear, it just moves. It becomes the cosmic microwave background. It becomes the infrared background. The energy is still there. The universe hasn't stopped broadcasting. It's just broadcasting on frequencies you weren't born to receive. And that uncomfortable feeling you had when you first heard about Olbers' paradox, that sense that something didn't quite add up, that the sky was somehow too dark, that instinct was right. The universe is broadcasting constantly on every channel at once. Darkness, as we'll see, was never a real condition, only a perceptual one. Part 3. The First Hidden Sky, CMB Reveal. In 1964, two engineers at Bell Laboratories in New Jersey accidentally discovered the oldest light in the universe. That sentence still doesn't sound quite real to me, no matter how many times I read it. Arno Penzias and Robert Wilson were not looking for the oldest light in the universe. They were trying to calibrate a large horn-shaped antenna that Bell Labs had built to detect radio signals bouncing off early communication satellites. The antenna was extremely sensitive, which was the point, and because it was so sensitive, it kept picking up a persistent, low-level hiss of noise that Penzias and Wilson could not account for or eliminate. They were meticulous about this. They checked every possible local source. They checked for interference from New York City, even though the antenna wasn't pointed that way. They checked for electrical problems in the instrument itself. They cleaned the antenna, which had accumulated some pigeon droppings, and in the history of science, that has to be one of the most beautifully unglamorous moments, and the noise persisted. They temporarily evicted a pair of pigeons nesting in the antenna. The noise persisted. What was left, after eliminating every earthly explanation, was a signal arriving uniformly from every direction in the sky, at a temperature of about 3.5 Kelvin above absolute zero. That temperature would later be refined to 2.725 Kelvin. And when they compared notes with a team of cosmologists at Princeton who had been theoretically predicting exactly this kind of background radiation, the pieces clicked together into something enormous. The noise was not an equipment malfunction. It was not local interference. It was the echo of the Big Bang. Here's what that signal actually is. In the first few 100,000 years after the Big Bang, the universe was too hot for atoms to exist. Protons and electrons were separate, moving too fast and carrying too much energy to bind together, and in that state the universe was opaque, Photons couldn't travel far before smashing into charged particles. The universe was essentially a dense fog of energy. Then, at around 380,000 years after the Big Bang, a moment cosmologists call recombination, the universe had expanded and cooled enough that protons and electrons could finally combine into neutral hydrogen atoms. And the moment that happened, the fog lifted. Photons that had been scattering around and bouncing off charged particles were suddenly free to travel in straight lines across the universe. Those photons have been traveling ever since. 13.8 billion years of uninterrupted travel, stretched by the expansion of the universe from their original, visible, and near-infrared wavelengths down into the microwave range. And they arrive at your skin from every single direction simultaneously. The sky, when you tune your detector to microwaves, is not scattered points of light on a black background. The sky is a uniform, glowing sphere. Every direction is equally bright. There is no dark sky. There is only an unbroken dome of ancient light. The numbers here matter because they make this feel real rather than abstract. About 411 of these photons occupy every single cubic centimeter of space anywhere in the observable universe. Not just near galaxies, not just in special locations, everywhere. The center of the most barren intergalactic space has 411 cmb photons per cubic centimeter. The space between your atoms has 411 cmb photons per cubic centimeter. The universe is permeated, saturated, soaked with this radiation at a level so uniform that when physicists measure variations in its temperature across the sky, those variations, tiny patches slightly warmer or cooler than average, are only about 1 part in 100,000, 100,000th of a degree. Think about what that means. The most precise measurement of the cosmic microwave background reveals a universe so stunningly uniform in its earliest detectable state that the tiny variations we do find are the seeds from which everything, every galaxy, every star, every planet, every one of us, eventually grew. The slight clumping you see in that temperature map, the faint hot spots and cold spots that WMAP and Planck have now mapped in extraordinary detail, those are the quantum fluctuations from the inflationary epoch that became, over billions of years, the entire large-scale structure of the cosmos. We are the grandchildren of a microwave afterglow. And here's the part that I find personally extraordinary. That light, the light from the moment the universe became transparent for the first time, that light is currently passing through you. Right now, as you sit wherever you're sitting, the first light of the universe is arriving at your skin. It has been arriving at your skin since before you were born. It has been arriving at every surface on Earth since the Earth formed. The first photons ever to travel freely through the cosmos are still traveling, still arriving, still interacting with matter, and they have been doing so for the entire history of our planet. The sky is already glowing, not in a frequency you were built to see, but in a very real, very physical, very measurable sense. You are bathed in ancient light at every moment of your existence. And what we've just described is only the first layer. There are others. Part 4. Reframe Hasson. Let's stop for a moment and really sit with what was just established, because the implications are bigger than they might appear on first pass. Imagine for a moment that you had microwave-sensitive eyes, not some science fiction modification, just a detector tuned to the 2.725 Kelvin radiation of the cosmic microwave background rather than to visible light. You walk outside on a clear night, you look up, and you see the sky is uniformly, completely, absolutely bright. Not bright like the moon, not bright like a street lamp, bright like a solid surface in all directions simultaneously. North, south, east, west, straight up, just above the horizon. Every direction you point your hypothetical microwave eyes, you receive the same signal. The sky has no dark patches. The darkness between the stars, gone. The vast black backdrop against which the Milky Way floats, gone. There is only the unbroken, omnidirectional glow of the oldest light in the universe. There is no night in microwaves. There's never been a night in microwaves. The entire history of life on this planet has unfolded inside a microwave oven, essentially, just one set to an extremely low temperature. Now here's the conceptual shift I want you to make. The visible sky that you know, scattered stars, black background, is not the default sky. It is not the baseline sky. It is not the real sky that all the other skies deviate from. It is one sky among many. It is one channel of information among many. And crucially, it is a minority case. The visible electromagnetic spectrum is such a tiny slice of the total spectrum that it makes more sense to think of visible light as the exception and all the other forms of radiation as the rule. The reality of the universe, if you could see all of it simultaneously, is not darkness with some bright spots in it. It's brightness with a particular dimming artifact in one specific narrow band that happens to correspond to the range your eyes can detect. You have been living your whole life with the impression that the universe is mostly empty and dark, and that impression is entirely a product of the fact that your detectors, your eyes, are tuned to the one frequency range where the universe happens to broadcast the least uniformly. What about all the other frequencies? What do they show? Well, we've got the microwave background, but that's just the oldest layer. On top of it, or rather alongside it, in a completely separate but simultaneous broadcast, there is a visible light background, the cumulative glow of every star that has ever existed. There's an infrared background, the reprocessed light of stars absorbed and re-emitted by cosmic dust. There's an X-ray background, the accumulated radiation from accreting black holes and active galactic nuclei scattered across billions of years of cosmic history. There's a gamma-ray background, a radio background that doesn't fit any of our current models. Each of these is its own sky. Each is omnidirectional. Each is constant. Each is arriving at your body right now. And we haven't even gotten to the things that aren't technically light at all, the neutrinos, the gravitational waves, the vacuum fluctuations. But we'll get there. The key insight for right now is this. The darkness you see when you look up is not the universe's condition. It is your condition. It is a perceptual gap, a biological blind spot, so comprehensive that it encompasses roughly 99.9% of the energy the universe is broadcasting at you right now. The sky isn't dark. It's broadcasting on channels you weren't built to receive. And the more we peel back those channels, the more we find the same thing at every frequency. Brightness, presence, signal. There is no channel of silence. There is no wavelength of nothing. The universe has never, not for a single moment in its entire 13.8 billion year history, stopped broadcasting. What stacks up from here is not one more exception or one more interesting corner case. It's the pattern itself. The sky doesn't just glow in one frequency. It stacks layer on layer on layer. And we are just getting started. Part 5. The light of everything that ever existed. Every photon that has ever been emitted is still in the universe. That's not a metaphor. It's not poetry. It is a literal statement of physics. Photons don't decay. They don't have a half-life. They don't spontaneously stop existing. Unless a photon is absorbed by matter, unless it runs into something and transfers its energy, it will travel at the speed of light through the universe indefinitely. And the universe is not infinitely full of matter to absorb them. Most photons, once emitted, travel for an extraordinarily long time before they encounter anything. This means that the light produced by the very first stars, population 3 stars, massive and hot and burning with the pure hydrogen and helium of the early universe, which formed roughly 100 to 200 million years after the Big Bang, some of those photons are still traveling. They've been redshifted by the expansion of the universe, pushed from ultraviolet down through visible into infrared, stretched further and further toward longer wavelengths. But they exist. They are in the universe right now. The light of the first stars that ever formed, the light from objects that burned out and collapsed before the Earth had any meaningful material to form from, is currently propagating through the cosmos. And not just those photons. The light from every star, in every galaxy, across every epoch of cosmic history, all of it persists. All of it adds up. The cumulative, integrated, total light of all cosmic history has a name, the extragalactic background light, or EBL, and measuring it turns out to be one of the most technically challenging experiments in modern astrophysics, because you're trying to detect an extremely faint, diffuse glow against a background that includes a lot of interference from much closer sources. The problem with measuring the EBL from Earth is that the solar system itself is full of dust, the zodiacal dust cloud, a broad disk of fine particles left over from the formation of the solar system that scatters and reflects sunlight and creates a diffuse glow called the zodiacal light. That glow overwhelms the faint cosmic signal. You need to get outside it. And one probe actually did. New Horizons, the spacecraft that flew past Pluto in 2015 and is now in the outer reaches of the solar system, far beyond the zodiacal dust cloud, has been used to measure the EBL with an unprecedented level of directness. In 2021, a team published results using New Horizons' LORRI camera, a long-range reconnaissance imager, pointed at patches of sky far from any bright sources. They carefully subtracted every known contributor, known galaxies, stars within the Milky Way, everything in their catalogue. And what remained was a faint residual glow. The headline number from that measurement was roughly 11 nanowatts per square meter per steradian in the optical band. If that number doesn't mean anything to you yet, let me contextualize it. If you were to collect all the light arriving at a surface the size of your outstretched hand from the EBL, you would be collecting an amount of energy roughly comparable to a standard LED nightlight viewed from about a mile away. It's faint. It's incredibly faint by the standards of everyday experience. But here's the remarkable thing. It is about twice as bright as the light that can be accounted for by counting all the known galaxies and adding up their output. Read that again. The integrated light of all the galaxies we can see and catalogue accounts for roughly half of the EBL signal that New Horizons measured. The other half is unaccounted for. It's coming from somewhere, but we don't know where. The universe, already demonstrated to be brighter than your eyes can detect, is also brighter than our telescope's inventories predict. There is more light out there than we know how to explain. Possible explanations include galaxies too faint to individually resolve, intra-halo stars, stars that exist between galaxies rather than within them, stripped out of their home galaxies by gravitational interactions, and potentially entirely new source categories that current catalogues don't capture. The point is, the universe is so thoroughly full of photons that we're having trouble accounting for all of them. The darkness of the night sky is not evidence of a quiet universe. It's evidence of the limits of our catalogues. And this is the important connection to the central argument. Every one of those photons is real. Every one of them is in transit. Every one of them is arriving at every surface in the cosmos simultaneously. The night sky doesn't just contain the light of stars you can see. It contains the cumulative light of every stellar event that has occurred across 13.8 billion years of cosmic history. The visible sky is a tiny window. What's actually streaming through that window, and through all the windows you can't see, is everything that has ever happened. Every photon ever emitted is still travelling, which means the universe is not only bright now, it has been accumulating brightness continuously, compounding it since the moment the first star ignited. And half of that light, as we're about to see, never made it to visible wavelengths at all. Part 6. The hidden half of the universe. Here's a fact about the universe that sounds like an exaggeration but is not. Roughly half of all the starlight ever produced has been absorbed by dust before it could reach you. Not lost, absorbed and re-emitted, transformed, changed in character but not eliminated, because dust, like everything else in the universe, does not make energy disappear, it converts it. When ultraviolet and optical light from stars hits a dust grain, a tiny solid particle of silicates or carbonaceous material floating in interstellar or intergalactic space, the grain absorbs that energy and heats up, and a warm dust grain emits radiation. At the temperatures typical of interstellar dust, somewhere between 10 and 100 Kelvin, the emission peaks in the far infrared at wavelengths between roughly 100 and 200 microns. Wavelengths far beyond what your eyes can detect, far beyond even the near infrared that some cameras can capture. Deep infrared, invisible. This is the cosmic infrared background, or CIB. It was first definitively detected by the COBE satellite, the Cosmic Background Explorer, in the 1990s, the same instrument that first mapped the temperature variations of the cosmic microwave background in detail. And the CIB turns out to be roughly comparable in total energy to the optical and UV light that escaped without being reprocessed. The universe essentially has two light systems operating in parallel: the direct starlight that travels freely in short wavelengths, and the dust reprocessed version of all the starlight it absorbed, released at longer wavelengths. Two separate budgets, two separate channels, both adding to the universe's total brightness. This matters for our central argument because it closes a potential loophole. Someone might say, okay, but at least in the visible range, space really is dark, right? At least in the channel my eyes can see. And the answer is, not entirely, as we established with the EBL. But more importantly, even if you accepted that premise, the energy doesn't vanish. Every photon of starlight that gets absorbed by dust and re-emitted in the infrared is a photon that is still in the universe, still traveling, still arriving at every surface everywhere. The light you can't see isn't absent. It's been redirected. The universe is still broadcasting it. You're still inside it. Darkness in the visible doesn't mean darkness across the board. It means the energy moved to a channel you can't access. The CIB is one more layer of the hidden sky, one more frequency band in which the universe is uniformly glowing at every moment. One more piece of evidence that the physical baseline condition of the cosmos is not darkness, but suffusion. You are surrounded. You always have been. Part 7. The violent sky you can't see. In 1962, just 2 years before Penzias and Wilson accidentally discovered the microwave background, a physicist named Riccardo Giacconi launched a small rocket experiment and detected, for the first time, X-rays coming from outside the solar system. It was the first observation in X-ray astronomy. Giacconi would go on to win the Nobel Prize in Physics in 2002, partly for this work. But what he stumbled into that night was something that would eventually reveal another layer of the universe's hidden brightness. A sky full of X-rays arriving from every direction, a background of high-energy radiation produced primarily by material being devoured by black holes across the entire history of the universe. The X-ray background, and above it the gamma-ray background, represent the universe's most energetic channels. X-ray photons have energies roughly 1,000 times greater than visible light photons. Gamma-ray photons push beyond that by another factor of thousands. These are not gentle forms of radiation. An X-ray photon passing through your body is carrying enough energy to ionize atoms along its path. It's the same physics that makes medical X-rays work. And these photons are arriving from every direction in the sky at every moment, produced by the accretion disks of active black holes, by the jets of blazars, galaxies with relativistic jets pointed directly at us, by neutron star mergers, by supernovae, by processes we are still cataloguing. The key point for our purposes is the same one that applies at every wavelength. These signals are omnidirectional. They are not concentrated in specific sky locations. They form a background, isotropic, or nearly so, meaning equal in all directions. Another sky, another layer of the universe's constant, unrelenting brightness in a channel you were never built to detect. You walk through X-rays daily. You walk through the gamma-ray background. You are permeable, in every direction, to the most violent processes in cosmic history. The universe's entire record of black hole feasting and neutron star collision and relativistic jet activity is encoding itself onto your body in real time. Not dangerously, the flux is far too low to cause biological effects, but physically, measurably, continuously. Part 8. The sky that shouldn't exist. Let's talk about something that is, frankly, embarrassing for modern astrophysics in the best possible way. In 2009, a balloon-based experiment called ARCADE-2, the absolute radiometer for cosmology, astrophysics, and diffuse emission, second version, was launched to measure the radio background with high precision. The team expected to confirm earlier measurements and refine the numbers. Instead, they found something that still doesn't have a clean explanation. The radio background is about 5 times brighter than theoretical models predict. Not marginally brighter, not within the error bars, 5 times. The extra radio signal is coming from all directions. It's been confirmed by multiple independent observations, and the sources that we know about, known galaxies, known radio bright objects, account for only a fraction of it. Something is producing a vast excess of radio emission that current models simply cannot locate or explain. The candidates that physicists have considered include populations of faint galaxies below the detection threshold of current surveys, diffuse emission from the cosmic web itself, the vast filaments of matter connecting galaxy clusters, and more exotic possibilities that get into speculative physics, including some models involving dark matter decay or annihilation. None of these explanations has been confirmed. None of them is fully satisfying. What the ARCADE-2 result tells us, setting aside the mystery of its origin for a moment, is that our best theoretical models of the universe's electromagnetic output systematically underestimate the actual brightness of the universe. At radio wavelengths, the universe is generating more signal than we know how to account for. This is not a small correction to a calibration. This is a factor of 5 discrepancy. Somewhere in the cosmos, there are radio photons being produced at an extraordinary rate by a source or sources we haven't identified. And in the context of our central argument, that's one more confirmation of the same theme. Every time we point a detector at the sky in a new frequency range, or with new precision, we find more brightness than we expected. The universe has never, not once, turned out to be dimmer than predicted when we improve our measurement capability. It has always been brighter. Every new instrument, every new frequency, every new generation of detector finds more light than the last one did. The darkness is always in the detector, never in the sky. Part 9. The second afterglow. We've spent some time establishing that the sky is full of photons at every electromagnetic wavelength, a layered, omnidirectional, historically accumulated flood of light that your eyes can almost entirely not detect. But photons are only one form of information the universe is broadcasting through you right now. And in some ways, they're not even the most fundamental. 1 second after the Big Bang, the universe was already a very different place than it had been a fraction of a second earlier. Temperatures had dropped from incomprehensible peaks to a mere 10 billion Kelvin, which is still 100,000 times hotter than the center of the sun right now, but in cosmic terms, cooling down. The universe at this point was a churning sea of quarks, gluons, electrons, positrons, photons, and neutrinos, all interacting constantly and furiously, locked together in a thermal equilibrium where energy was distributed evenly among all particle types. Everything was in contact with everything else. And then something happened to neutrinos. As the universe expanded and cooled, the rate of neutrino interactions, the collisions and scatterings that kept them in contact with the rest of the plasma, began to fall below the rate of expansion. There's a threshold temperature, about 2 or 3 MeV in particle physics units, where neutrinos stop interacting frequently enough to stay coupled to the photon-electron-positron plasma. They decouple, they freeze out, they stop feeling the rest of the universe and start simply streaming freely through it. This happened when the universe was approximately 1 second old, 1 second, and those neutrinos, the ones that decoupled from the cosmic plasma when the universe was 1 second old, are still here. They never annihilated. They never got absorbed. They've been streaming freely through the expanding universe for 13.8 billion years, and they fill every cubic centimeter of space with a density of roughly 336 particles. Not 336 per square meter or per liter, 336 per cubic centimeter, the volume of a thimble everywhere at all times. This is the cosmic neutrino background, or CVB, and it is in a very real sense a second afterglow, an afterglow from a moment that predates the photon-releasing recombination event by 379,000 years. The neutrino background is an echo of a more ancient universe than even the microwave background. The CMB shows us what the universe looked like 380,000 years after the Big Bang. The neutrino background, if we could detect it properly, would show us what the universe looked like at 1 second old. The temperature of the cosmic neutrino background is 1.95 Kelvin, colder than the microwave background because neutrinos decoupled earlier, before electrons and positrons annihilated and dumped extra energy into the photon bath. They missed that energy boost. They're fractionally cooler, but they're there. 336 of them in every cubic centimeter of your body, billions passing through you every second. Here's what makes this genuinely strange. A neutrino detector, one of the real working neutrino detectors like Super Kamiokande in Japan or Ice Cube in Antarctica, cannot directly detect the cosmic neutrino background. The CVB neutrinos have such low energies compared to neutrinos produced by the Sun or by supernovae that even our most sensitive neutrino telescopes cannot catch them. We know they're there from theoretical calculations that have been confirmed by precision measurements of the CMB and the large-scale structure of the universe, but we've never directly seen them. There's a proposed experiment called Ptolemy that might eventually be able to detect them using a very specific nuclear interaction with tritium, but as of now, the cosmic neutrino background remains the only component of the standard cosmological model that has never been directly observed. And yet, they're there, in you, right now. You are being permeated by the oldest detectable particles in the universe, particles that decoupled from the rest of matter before your atoms existed, before the atoms of Earth existed, before the atoms of the Sun existed. If the cosmic microwave background photons are old, the cosmic neutrino background particles are ancient in a way that genuinely defies easy comprehension. The darkness you think surrounds you is not just full of photons. It is full of matter, particle matter, the kind of thing that has mass that interacts, however weakly, with the same fermion fields that compose your body. You are made of matter, and you are constantly bathed in the oldest matter in the universe. The universe has been intimate with you since before you existed, in ways you've never been able to perceive. Part 10. The moment 1 second after creation. Let's try to actually picture where these neutrinos come from. Not just the physics, but the experience of that moment, as best as physics allows us to reconstruct it. 1 second after the Big Bang. The universe is approximately 10 billion kilometers across, smaller than the current solar system's outer extent, though the geometry of early spacetime means that comparison is imprecise. Into that volume is compressed everything, all the matter and energy that will eventually become 2 trillion observable galaxies, 400 billion stars in the Milky Way alone, the 7,800,000,000 people alive on Earth right now, every ocean and continent and mountain range, every book ever written, every signal ever broadcast, all of it is compressed into that volume, at a temperature 10 billion times hotter than the Sun's corona, at a density that makes the core of a neutron star look spacious. In this environment, every particle type is in constant, furious contact with every other particle type. Neutrinos are colliding with electrons and positrons and photons and quarks. Energy is distributing itself uniformly across all channels. The universe is, in a sense, perfectly mixed, perfectly thermalized, perfectly coupled. There are no independent streams of information yet, no separate channels. Everything is one system. And then the temperature drops just enough. The expansion of the universe stretches the distances between particles, and the rate of neutrino scattering, which falls steeply with decreasing temperature, drops below the Hubble rate. Neutrinos go from interacting multiple times per second to almost never interacting. The coupling breaks. In the language of cosmology, the neutrinos freeze out. And from that moment forward, they are no longer part of the rest of the cosmic story in any meaningful thermodynamic sense. They become spectators. Those spectator neutrinos from 1 second after the Big Bang are the ones filling your body right now. They have watched every subsequent act of cosmic history, the formation of the first atoms at recombination, the growth of the first stars and galaxies, the formation of the Milky Way, the formation of the Sun, the formation of the Earth, all of it, while traveling freely and interacting with essentially nothing. They have been present for the entirety of cosmic history as silent, ghost-like observers. And now they're passing through you, not stopped by you, through you. Your body is transparent to them, which is the only reason they're still everywhere. 336 per cubic centimeter, 13.8 billion years later. If they interacted readily, they'd have been absorbed long ago, and the cosmic neutrino background would have been depleted. Their weakness is what preserves them. They have to be nearly invisible to survive. What this means for the argument we're building is important. The universe is not just broadcasting in electromagnetic radiation at every wavelength simultaneously. The universe is also broadcasting in particles, fundamental, massive matter particles that have been in free flight since 1 second after the Big Bang. Before atoms existed, before starlight existed, before the cosmic microwave background was released, the neutrino background was already established. Darkness, even in the earliest conceivable sense, was already not an option. The universe was seeded with signal before it was transparent to light. You are, in this very moment, inside a particle stream that originated in the first second of existence. That stream has never stopped. It will never stop, not on any timescale relevant to human comprehension, or indeed to the existence of the current universe. The universe is not broadcasting to you. The universe is broadcasting through you, and you've been inside that broadcast every moment of your existence without ever knowing it. Part 11. The universe is vibrating. In June of 2023, the North American Nanohertz Observatory for Gravitational Waves, NanoGrav, announced what may be one of the most significant detections in the history of observational astronomy. They had found evidence for a gravitational wave background, not a single gravitational wave event, like the ones LIGO detects when 2 stellar mass black holes collide. A background, an omnipresent, stochastic hum of gravitational waves arriving from all directions simultaneously. Let me explain what gravitational waves actually are, because calling them ripples in space-time doesn't quite capture the strangeness of them. When Einstein developed general relativity, he showed that mass and energy don't just sit in space, they warp space. Mass bends the geometry of the space around it, and that bending is what we experience as gravity. Now, when massive objects accelerate, especially when they orbit each other, and especially when they're very massive and moving very fast, they don't just warp space statically, they generate propagating distortions in the fabric of space-time itself. These distortions travel outward at the speed of light. They are not waves traveling through space. They are waves of space. When a gravitational wave passes through you, it physically stretches and squeezes the space you occupy. Distances actually change, fractionally. The atoms in your body are slightly farther apart and then slightly closer together as the wave passes. For the gravitational waves that LIGO detects from stellar mass black hole mergers, the stretching is roughly 1 part in 10 to the 21st, far smaller than the diameter of a proton, across the entire length of a 4-kilometer detector arm. It is a stupefyingly small effect, but it is real, it is measurable. Space physically changes shape. The gravitational wave background detected by nanograv is produced primarily by pairs of supermassive black holes, the ones that sit at the centers of galaxies, with masses millions to billions of times that of the Sun, in the final stages of their in-spiral before merging. These pairs, spread across the entire observable universe at every stage of their orbital evolution, collectively produce a stochastic hum that never stops, because there are so many of these pairs at so many different stages that the contributions overlap into a continuous background signal. Nanograv detected this using pulsar timing arrays. Millisecond pulsars, rapidly rotating neutron stars that emit radio pulses with extraordinary regularity, effectively acting as cosmic clocks, can be monitored across years and decades, and the passage of gravitational waves subtly alters the apparent timing of their pulses as space between us and them stretches and compresses. By monitoring dozens of pulsars across the sky and looking for correlated timing variations, Nanograv was able to infer the presence of the background. What this adds to our picture is conceptually profound. We've established that the universe is broadcasting in photons at every electromagnetic frequency and in matter particles in the form of the neutrino background. Now we can add, the universe is also broadcasting in space-time distortions. There is no channel that is silent. There is no mode of physical information propagation that is not carrying a background signal from the accumulated history of cosmic events. The gravitational wave background means that the very geometry of the space your body occupies is never perfectly still. It is constantly, gently, invisibly vibrating with the echoes of mergers between billion solar mass black holes that happened billions of light years away and billions of years ago. Space-time itself is not quiet. Space-time is humming. You are sitting inside that hum right now and have been your entire life. Darkness was never the condition of the universe, not in light, not in particles, not even in the fabric of space itself. Part 12. Reframe #2. So let's build the full picture. Let's stack the layers and see what we actually have. Start with the electromagnetic spectrum. At the lowest frequencies, you have the radio background, including the unexplained excess detected by Arcade, 5 times brighter than models predict, arriving from all directions simultaneously. Move up in frequency, and you have the microwave background, the cosmic microwave background, the oldest light in the universe. 411 photons per cubic centimeter, uniform to 1 part in 100,000, arriving at your skin from every direction at every moment. Continue up, and you have the infrared background, both the near-infrared and the far-infrared, the latter representing the entire reprocessed half of all starlight ever produced, absorbed by dust and re-emitted at wavelengths far beyond your eye's reach. Then the optical and ultraviolet background, the extragalactic background light, the cumulative glow of every star in every galaxy across all cosmic time, about twice as bright as our galaxy catalogues predict. Then the X-ray background, the accumulated emission of accreting black holes and hot gas across cosmic history, omnidirectional, constant. Then the gamma-ray background, the most energetic photons in the universe, arriving continuously from blazars and gamma-ray bursts and active galactic nuclei distributed across the entire observable volume. Every single one of those backgrounds is omnidirectional. Everyone is constant. Everyone is arriving at your body right now. None of them requires a special location or special conditions. They are the baseline condition of every point in space in the observable universe. Now add the particle background. 336 cosmic neutrinos per cubic centimeter, every cubic centimeter, everywhere, produced 1 second after the Big Bang and streaming freely ever since. Billions passing through your body every second, through your atoms, through your nuclei, interacting with essentially nothing, carrying information about the state of the universe at 1 second old. Now add the gravitational wave background. Space-time itself, constantly and gently distorted by the cumulative gravitational radiation of every supermassive black hole merger across cosmic history, arriving from all directions simultaneously, physically altering the geometry of the space your body occupies at levels too small to feel, but not too small to measure. And remember, we haven't even mentioned what happens at the quantum level in the vacuum itself. We haven't yet gotten to the Casimir effect, the Lamb shift, the cosmological constant problem, the evidence that even empty space, with all matter removed, is not actually empty. When you lay all of this out simultaneously, what you get is not a universe with some light in it. You get a universe that is comprehensively, thoroughly, unavoidably suffused with signal in every physical channel that exists. There is not a single mode of information propagation, not a single frequency, not a single particle type, not a single physical degree of freedom that is not actively carrying a background signal right now. The question then becomes, where could you possibly go to get away from it? If the baseline condition of the universe is this level of omnidirectional signal at every frequency, is there anywhere that's actually darker? Is there a place where the signal drops to zero, or even just to a level that's meaningfully different from everywhere else? The answer to that question is why we're going to the Boötes Void. Because if there's anywhere that should be darker, anywhere that should represent a genuine departure from the broadcast, it's there. And what we're going to find when we get there is going to resolve the last remaining refuge of the idea that darkness might be real. But first, let's check the places closer to home. Because even before we go to the emptiest known region of the universe, the illusion has already broken down in places you might think would be easy wins for darkness. Part 13. Earth is already glowing. The darkest sky on Earth is not dark. This sounds like a cheap rhetorical trick, but bear with me. The International Dark Sky Association maintains a list of designated dark sky reserves, places like the Atacama Desert in Chile, the Tibetan Plateau, Mauna Kea in Hawaii, the Roque de los Muchachos Observatory in the Canary Islands, where artificial light pollution is minimal and the sky is about as dark as it gets on this planet. Astronomers have fought hard for these locations. They matter enormously for science, and they are, by any human standard, very dark. But even at the darkest of these sites, even on a moonless night with perfect atmospheric transparency, the sky is not at optical zero. Your eye, fully dark adapted after 30 minutes in total blackness, will still perceive a faint glow across the entire sky from a phenomenon called airglow. Airglow is the chemiluminescent emission of the upper atmosphere. Molecules like oxygen and hydroxyl, excited by solar radiation during the day, slowly releasing that energy as light during the night. On a truly dark night, airglow contributes roughly as much light to the sky as all the stars combined. It's everywhere, it never turns off, and it means that from the surface of Earth, you are never seeing a truly dark sky even in the optical band. Beyond airglow, you have the zodiacal light, the reflection of sunlight off the disk of interplanetary dust within the solar system, which appears as a faint pyramid of light along the ecliptic. You have cosmic rays constantly arriving from outside the solar system, producing faint flashes in the atmosphere and in your retinal cells when they happen to land on them. You have the thermal emission of the atmosphere itself. You have scattered light from the Milky Way. Layer on layer on layer. Even invisible light, even on Earth. The sky at its darkest is still the product of dozens of overlapping signals. And all of that is before you turn on the microwave channel, the infrared channel, the radio channel, before you add the neutrino rain, before you add the gravitational wave background. The Earth, far from being a place where darkness can be found, is one of the brightest locations in the universe in terms of the number of active signal sources in its immediate vicinity. You have a G-type star 3,300 radii away. You have a magnetosphere interacting with the solar wind. You have an atmosphere glowing all night. You are, even at your darkest midnight in the world's most remote location, completely surrounded. Part 14. Step into space. Step away from Earth. Float free, between the planets, far enough from any surface that airglow and terrestrial emission are no longer relevant factors. You're in the inner solar system, maybe halfway between Earth and Mars, and it's as quiet as the local neighborhood gets. From here, the sun is still an overwhelmingly dominant source of visible light, so much so that if you opened a window on a spacecraft here without eye protection, you would be blinded. The sun represents the one instance where human visible light is actually very intense in space. But the moment you look anywhere except at the sun, the sky looks black to your eyes. Stars are visible, brighter than from Earth because there's no atmospheric scattering or airglow, but the space between them looks empty. This appearance is a physiological artifact. Your retina is adapting to the dominant light source in the scene. When you look at the sun, or in the sun's direction, your pupil contracts and your retina desensitizes to handle the enormous brightness. When you look away from the sun, toward the stars, your eye has not had time to readapt to low light conditions, and the stars, though they appear bright against the dark background, are actually receiving far less light from distant sources than the sun is contributing to the overall scene. Your brain fills in the background as black because there's not enough signal to trigger a response from your retinal cells in those regions. But the microwave background doesn't care about your pupil. The 411 cmb photons per cubic centimeter are still there. The infrared background is there. The neutrinos are there. You are in the inner solar system, bathed in solar wind, a continuous stream of charged particles ejected from the sun, and simultaneously bathed in the light of all cosmic history. Remove the solar wind's contribution for a moment, and the baseline cosmic signal is the same here as it is anywhere else in the observable universe. You haven't escaped anything. You've just changed your local light pollution. The darkness you would perceive here is the same kind of darkness you perceive on Earth, a perceptual response to the inadequacy of your detector, not a physical absence of signal. The universe is broadcasting at full volume in this location, as it is at every location. Part 15. The Moon's Far Side. Push farther. Go to the most extreme location any human has ever stood, or that any rover has ever visited from the perspective of isolation, the far side of the Moon. Specifically, a location near the lunar South Pole, where Earth never rises above the horizon, where the sun is currently below the horizon, where you're inside a permanently shadowed crater that last saw direct sunlight before the Earth existed. No atmosphere, no airglow, no earthlight, no sunlight. The electromagnetic environment, by all surface-level human intuitions, should be about as empty as anything on a rock in the inner solar system can be. The silence here, acoustic silence, but also the general absence of local activity, would be total. The cosmic microwave background is here. 411 photons per cubic centimeter, arriving from every direction, including the ones blocked by the Moon beneath your feet. The half of the sky that the moon's bulk blocks from your view is irrelevant because the CMB is omnidirectional. There's just as much of it coming up through the moon's bulk as there is coming from the open sky above, in the sense that the background is isotropic across the whole sphere and you're inside it regardless of what's in your way. The cosmic neutrino background is here in full force. Neutrinos pass through the moon as though it doesn't exist. Every cubic centimetre of your spacesuit, your body, the crater floor, the moon's entire bulk, all of it is permeated by 336 cosmic background neutrinos per cubic centimetre. The moon is not a shield against the universe's particle background. Cosmic rays arrive here. In fact, they arrive here without the atmospheric shielding that Earth's surface provides, which is why long-duration lunar surface stays present, a radiation challenge for human health. High-energy charged particles from sources across the galaxy and beyond hit the lunar surface continuously, and when they do, they produce a very faint gamma-ray glow from the surface itself as the particle interactions generate secondary radiation, and the gravitational wave background hums here as it does everywhere. The geometry of the space-time the moon occupies is being continuously, slightly deformed by the accumulated gravitational radiation of cosmic black hole mergers. No location in the universe is exempt from this. The quietest place humans have ever stood is not quiet. It is physically indistinguishable from the perspective of cosmic background signals from your living room. The universe does not thin out as you move away from complex planetary environments. The cosmic baseline is constant. The background is everywhere. Part 16. A universe without night. Before we make our final journey to the actual emptiest known region, it's worth pausing on a thought experiment that flips the perspective entirely. Everything we've discussed has been about why space seems dark, even though it isn't. But what would it look like if you were somewhere in the universe where it couldn't even seem dark? Omega Centauri is a globular cluster, a spherical collection of several million stars that orbits the Milky Way as a satellite system. At its center, the density of stars is extraordinary by our standards. If you lived on a planet at the center of Omega Centauri, the nearest stars to you would be roughly 1/10 of a light year away, about 300 times closer than the nearest star to Earth. In the night sky from such a planet, there would be no dark gaps. The sky would be filled so thoroughly with nearby bright stars that no direction of view would give you a patch of optical darkness. There would be no night, not in the way we understand it. The sky would be bright in multiple directions simultaneously at all times, from stars close enough and bright enough that the combined visible light output would maintain a continuous twilight, or possibly brighter. For life evolving on such a planet, the sky is dark would be a false statement even in visible light. The night sky being fundamentally dark, that intuition, that background assumption we all carry around, is not a universal feature of the cosmos. It's a local anomaly. It's a product of our particular location in a relatively sparse region of the outer disk of a spiral galaxy, where the nearest stars are over 4 light-years away, and the average direction of view in visible light gives you more background than bright source. The darkness of our night sky is not a fundamental truth about the universe. It's a neighborhood observation, and neighborhoods vary. Part 17. Enter the Void. In 1981, a team of astronomers led by Robert Kirshner published the results of a redshift survey of galaxies in a region of sky in the constellation Boötes, the herdsman. They were cataloguing the large-scale distribution of matter, trying to map the 3-dimensional structure of the universe on the largest scales. What they found was not what anyone expected. In one direction, roughly centered on the constellation Boötes, there was a region of space approximately 330 million light-years across that was almost completely devoid of galaxies, not sparse, not underdense by some factor, near empty, a sphere of space larger than most of the structures in the known universe, containing perhaps 60 galaxies, where standard density models would predict 2,000 or more. Think about the scale for a moment. 330 million light-years. The Milky Way galaxy is about 100,000 light-years across. The local group, the Milky Way, Andromeda, and their associated smaller galaxies spans roughly 10 million light-years. The Boötes Void is 33 times the diameter of the entire local group. It is a structure of such extreme emptiness that it challenged, at the time, the developing models of large-scale cosmic structure. Astronomer Greg Botham famously joked, after the initial discovery, that the void was too big to be real. It was real. The Boötes Void has become, in subsequent decades, the gold standard for cosmic emptiness. Other voids exist. The cosmic web that describes the large-scale structure of the universe consists of dense filaments and galaxy clusters connected at nodes, with vast underdense regions called voids between them. But the Boötes Void is among the largest and best characterized of these structures. It has been studied and resurveyed multiple times, and while subsequent surveys have found a few more galaxies within its volume than the original count, it remains strikingly, anomalously empty by the standards of the observable universe. Now, what happens if you stand at the center of it? Your human intuition about this is correct, for once. If you could somehow be instantaneously transported to a point near the center of the Boötes Void and looked around in visible light, you would see almost nothing. The nearest galaxies are at the void's edge, more than 150 million light-years away in every direction. Even a bright galaxy at that distance would be an extremely faint smear of light, far below the brightness threshold of the naked human eye. In visible light, from the center of the Boötes Void, the sky would be darker than anything experienced at the surface of Earth, darker than the lunar farside in Earth night, darker than deep space within our own galaxy. It would be, by any visual standard, as close to genuinely dark as the observable universe can get. This is where the argument either wins completely or faces its hardest test, because everything we've established about the universe's hidden brightness needs to hold up even here, in the place most likely to be different. If there's anywhere that should break the pattern, anywhere that should be genuinely dark in all the ways we've been describing, the Boötes Void is where you'd look for it. And so, let's look. Part 18. The Experiment. You're there, the center of the Boötes Void. Your visible light view is, let's say, honest. It's what it's supposed to be, which is close to nothing. Stars of the Milky Way are not visible here because you're 100 million light-years from the nearest galaxy. The sky in human eye wavelengths is, genuinely and accurately, very close to optical black. For once, your eyes are not the limiting factor. The actual number of visible wavelength photons reaching your retina from the direction of the void's interior is simply extremely low. For once, the sky looks dark, and it is, at least in visible light, actually dark. Now let's start turning on the other channels. Microwave first. Tune your hypothetical detector to the frequency of the cosmic microwave background, and nothing changes. Or rather, everything changes, in the sense that the sky is now uniformly, completely bright. 411 photons per cubic centimeter, arriving from every direction with the same isotropy they show from Earth, from the lunar farside, from the inner solar system. The CMB doesn't thin out in voids. It doesn't pool in galaxy clusters. It fills the universe uniformly, and the Boötes Void is part of the universe. The microwave sky in the center of the Boötes Void is indistinguishable from the microwave sky as measured from Earth. A uniform glowing dome in every direction. Now add the infrared. The cosmic infrared background, the reprocessed starlight emitted by dust across cosmic history, is also isotropic, also present everywhere, also arriving at identical levels in the center of the void as it is in the center of the densest galaxy cluster. There are slight perturbations near large concentrations of matter, but you're so far from any large concentration of matter that those perturbations are irrelevant. The infrared sky in the Boötes Void is the same as it is everywhere else. Now add the optical background, the extragalactic background light, fainter but present. The cumulative glow of all stellar history is also here. In fact, measured locally, the contributions from the void's own extremely sparse galaxy population are lower, but the contribution from galaxies on the far side of the void, from all the galaxies of the surrounding cosmic web, arrives from every direction as a diffuse background that is essentially unchanged from what it is at any other point in space at this scale. Now turn on the X-ray channel. The X-ray background, produced by accreting black holes distributed across the entire observable universe, is here, omnidirectional, constant, coming through. Now the gamma-ray background, here. Now the radio background, present. Now the neutrino background, 336 cosmic background neutrinos per cubic centimeter of the center of the Boötes Void, passing through whatever hypothetical detector you're running, exactly as they pass through every other cubic centimeter of the observable universe, because neutrinos pass through everything. The void's near absence of galaxies doesn't affect the neutrino background any more than a patch of clear air affects a radio signal. Now the gravitational wave background, the stochastic hum of space-time distortion from supermassive black hole mergers distributed across the universe's history, present here, at the same level it is everywhere else. Because gravitational waves travel through matter and through vacuum with equal ease, and their background is as isotropic as the CMB. Here, in the emptiest known region of the observable universe, with no galaxies nearby, with no stars close enough to resolve, with a visible light sky that is as dark as anything the cosmos produces, every single other signal channel is performing at full strength. The baseline brightness of the universe doesn't care about galaxy distributions. It doesn't care about local matter density. It lives in the structure of space itself, in the particles and photons that decoupled from matter billions of years ago and have been filling the universe uniformly ever since. Part 19. The cathedral appears. Now turn everything on at once. All channels simultaneously, full spectrum. What you experience at this moment, in the center of the emptiest known place in the observable universe, with all physical signal channels active, is not darkness. It is not near darkness. It is not a slightly dimmed version of what you'd experience in a galaxy. It is the same total bath of omnidirectional cosmic signal that exists at every other point in the observable universe. The microwave sky, uniformly glowing. The infrared background, present from all directions. The optical background, faint but non-zero. The X-ray and gamma-ray backgrounds, arriving continuously. The neutrino rain, billions per second through every square centimeter. Space-time itself, gently vibrating with gravitational echoes. The Boötes Void does not represent a departure from the universe's baseline brightness. It represents a confirmation of it, because in the void, you've removed the one thing, local galaxy density, that might have produced interesting visible light variations. And you've discovered that stripping away that one variable doesn't change anything about the underlying signal environment. The void is filled with the same universe as the rest of the universe, because the universe's brightness doesn't depend on where the galaxies are. Think about what that means geometrically. The emptiest place is not empty. The place chosen specifically because it represents the maximum departure from the normal matter density of the universe is, from a signal environment perspective, essentially indistinguishable from the most galaxy-dense regions. The signals don't cluster with matter, they permeate the medium. The medium is the universe itself, not the matter in it. There's a way to think about this that I find genuinely moving. Imagine a cathedral, not in a religious sense, but architecturally, a space defined by its enclosure, by the surfaces that bound it. Now imagine a cathedral so large that its walls are the surface of last scattering, the origin of the CMB, 13.8 billion light-years away in every direction. Its floor and ceiling and walls are all made of that ancient glowing surface, and you're standing inside it at any point in the observable universe, and the light from those walls is reaching you equally from every direction, and it always has been, and it always will be, until the universe cools so much that even microwave photons redshift below any detector's reach, an event so far in the future it doesn't merit human concern. You are inside a glowing cathedral. You've always been inside a glowing cathedral. The walls just glow in a frequency you were never built to see. The void didn't break the argument. The void confirmed it, because the void is inside the same cathedral as everything else. The walls are equally bright from the void's center as they are from the center of the densest galaxy cluster. The only difference is the furniture. And the furniture, as it turns out, contributes almost nothing to the fundamental brightness of the universe. Part 20. Reframe, #3, peak moment. Let's state this as plainly as possible, because this is the moment the whole argument lands, and I don't want anything to get in the way of it. The Boötes Void is approximately 330 million light-years across. To give that number some context, the Milky Way galaxy, the entire structure containing our Sun and 400 billion other stars, is about 100,000 light-years in diameter. The Boötes Void is 3,300 Milky Ways wide. The local group, the Milky Way, the Andromeda Galaxy, and all their associated satellite galaxies, the entire gravitationally bound neighborhood we inhabit, spans roughly 10 million light-years. The Boötes Void is 33 local groups across. It is not a gap between galaxies in the way that you might picture a gap between houses on a street. It is a structure so enormous that if you placed our entire cosmic neighborhood at its center, the nearest galaxy clusters at the void's edges would be so far away that light leaving them right now would not reach us for over 150 million years. It is the largest, well-characterized underdensity in the observable universe. Surveys have found perhaps 60 galaxies within its volume, where standard cosmological models predict something closer to 2,000. That is not a slight underdensity. That is not a statistical fluctuation. That is a region of space that contains approximately 3% of the matter it should, by every model we have, contain. It is the universe's most serious attempt at emptiness. If the cosmos were trying to produce nothing, the Boötes Void is the closest it has come. And I want to be honest with you about what that means visually, because intellectual honesty matters here. If you were somehow standing at the center of the Boötes Void and looking around with your naked eyes, the sky would be extraordinarily dark by any human standard. The nearest galaxies are at the void's edges, more than 150 million light-years away in every direction. Even a moderately bright galaxy at that distance would be far below the detection threshold of the human eye, a smear of light so faint that no amount of dark adaptation would bring it into view. In visible wavelengths, the center of the Boötes Void is genuinely, substantially, meaningfully darker than anything you would experience standing in the darkest field on Earth on the clearest night of the year. That is the honest answer. The void wins on visible light. We should acknowledge that. And now let's talk about every other channel. The cosmic microwave background does not know the Boötes Void exists. It does not thin out in underdense regions or concentrate in galaxy clusters. It fills the universe uniformly. That's one of its defining characteristics, the thing that makes it cosmologically significant. And 411 photons per cubic centimeter in the center of the void is the same number as 411 photons per cubic centimeter in your bedroom, in the center of the densest galaxy cluster known, in the space between the plates of a Casimir experiment, in the interior of the Sun before they get absorbed by the solar plasma. The CMB is a property of the universe, not of the matter in it, The void changes nothing about it. The cosmic neutrino background does not thin out in the void either. 336 neutrinos per cubic centimeter, every cubic centimeter, everywhere, because neutrinos interact so weakly with matter that the near absence of matter in the void is completely irrelevant to their distribution. They pass through the matter that was once more uniformly spread across this region, back when the universe was younger and denser, and they have been streaming freely ever since, filling the void as thoroughly as they fill every other volume of space. The void's galaxies did not leave when the void formed. They migrated outward over billions of years under the influence of the surrounding large-scale structure, pulled toward the dense filaments and walls that define the void's boundaries. The neutrinos, interacting with nothing, noticed none of this. They are still here. They have always been here, 336 per cubic centimeter, as they are everywhere. The gravitational wave background hums through the void's spacetime. At precisely the same amplitude, it hums through the spacetime occupied by the most massive supercluster in the observable universe. Gravitational waves travel through matter and vacuum with equal ease. The near vacuum of the Boötes Void presents no more resistance to them than the densest regions of the cosmic web. The spacetime at the center of the void is being continuously, gently distorted by the accumulated gravitational radiation of supermassive black hole mergers distributed across cosmic history, arriving from every direction simultaneously, exactly as it is at every other point in space. The X-ray background is there, produced by accreting black holes distributed across the entire observable universe, accumulated across billions of years, traveling freely through the largely empty intergalactic medium. It arrives at the center of the void from every direction at the same flux it arrives everywhere else. The gamma-ray background is there. Blazars and active galactic nuclei and neutron star mergers across cosmic time have been producing gamma-ray photons for billions of years, and those photons do not avoid the void. The radio background is there, including the unexplained excess detected by Arcade, 5 times brighter than models predict, omnidirectional, constant, indifferent to local matter density. And here is the detail I want to make sure doesn't get lost. Even in visible light, the one channel where we acknowledge the void genuinely wins, the darkness is not absolute. It is not optical zero. The extragalactic background light, that faint, diffuse glow representing the cumulative optical emission of all cosmic history, arrives at the center of the void from the surrounding universe. The galaxies at the void's edges, and the vastly larger population of galaxies beyond them in every direction, contribute to a diffuse optical background that does not vanish just because there are no local sources. It is fainter than it would be from inside a galaxy cluster. It is fainter than it would be from the Milky Way. But it is not zero. Darkness in the center of the void, even in optical wavelengths, is very dark rather than absolute. The universe cannot produce optical zero either, even in its emptiest address. So, let's add this up with the precision it deserves. The Boötes Void, the universe's best attempt at emptiness, a volume 330 million light-years across containing 3% of its expected galaxies, the gold standard for cosmic nothing, fails to produce a location where the signal environment of every physical channel simultaneously drops to zero. It fails in every non-optical channel completely, with values indistinguishable from the universal baseline. And it fails even in the optical channel, producing very dark rather than truly dark. The universe's most serious attempt at emptiness still cannot generate the physical condition of silence. The conclusion of this experiment is not a metaphor. It is not a poetic reframing. It is a physical and specific and falsifiable statement. There is no location in the observable universe where the total signal environment across all physical channels simultaneously reaches zero. The universe's baseline condition is not silence. it is not darkness. It is the constant, omnidirectional, full-spectrum broadcast of everything that has ever happened. Still traveling, still arriving, still writing the information of cosmic history onto every surface and every particle and every unit of space-time at every point in the observable universe. Darkness cannot be reached. Not on Earth, where airglow and zodiacal light and cosmic rays ensure the optical sky is never at zero. Not in deep space, where the CMB and the neutrino background and the gravitational wave background perform exactly as they do everywhere else. Not on the lunar far side, where the absence of atmosphere removes all local effects and reveals the cosmic baseline in its clearest form. And not in the Boötes Void, where we gave darkness every possible geographic advantage and it still could not deliver. Darkness cannot be reached because it does not exist as a physical condition. It exists as a perceptual condition, a property of detectors with limited bandwidth, an artifact of instruments tuned to one narrow range in a universe that broadcasts across an effectively unlimited range. The universe has no limited bandwidth. It never developed one. It broadcasts everything it has ever done in every channel that physics provides, simultaneously, from every direction, at every point, without interruption. You started tonight with a night sky that looked dark and felt dark and seemed, by every available intuition, to be dark. You have now done the most charitable version of the experiment. You went to the darkest place the universe has produced, turned on every detector, and measured the result. The emptiest place is as bright as your room. Not in the frequency your eyes use. I want to keep being honest about that. But in every other frequency simultaneously, the void and your bedroom are physically equivalent environments. Surrounded, permeated, bathed, broadcast upon from every direction at once. There is no dark corner to retreat to. There is no frequency of silence. There is no location of absence. The universe does not produce these things because it does not have the mechanism to produce them, because everything it has ever emitted is still here, still moving, still arriving. There never was a dark corner. You were just standing in the light the whole time, with your eyes closed to most of it. Part 21. The brightest thing in creation. Since we are talking about the relationship between brightness and darkness, it is worth spending a moment on the most luminous known object in the universe. Partly for scale, and partly for a counterintuitive point it makes that I think will land harder than you expect. Tune 618 is a quasar. And if you have never heard that name before, hold on to it, because this thing is genuinely difficult to process at a human scale. A quasar is essentially an actively feeding supermassive black hole, a cosmic drain so massive that the material spiraling into it heats up to temperatures that make the surface of the sun look like a warm sidewalk, and in doing so, releases energy that can outshine entire galaxies. TON 618 is located about 10.4 billion light-years from Earth. The light we observe from it today left its source when the universe was roughly 3.4 billion years old, less than a quarter of its current age. We are, in a very real sense, looking at a fossil of the early universe every time we point a telescope at it. The black hole at its center has a mass of approximately 66 billion times the mass of the Sunday. Let that sit for a second. 66 billion solar masses. Our own sun is so large that you could fit 1.3 million Earths inside it. TON 618's black hole has the mass of 66 billion of those. It is not the largest structure in the universe. Galaxy clusters and cosmic filaments outweigh it by orders of magnitude. But as a single, gravitationally bound object, a single point of collapsed mass, it represents something close to the upper limit of what the universe seems willing to produce in that category. And the material accreting onto it, the gas and dust and stellar debris spiraling inward through a superheated disk, produces a luminosity of approximately 4.3 times 10 to the 40 watts. Now, 10 to the 40 watts is a number that needs translation. Our sun produces about 3.8 times 10 to the 26 watts. That means ton 618 is roughly 100 trillion times more luminous than the Sunday. Or, to put it another way, it is approximately 1 trillion times brighter than the entire Milky Way galaxy. Not one star in the Milky Way, not the combined output of the bright stars you can see on a clear night, but the total light output of all 400 billion stars in our galaxy combined, multiplied by 1 trillion. That is the luminosity of one object, one black hole's lunch. From a certain distance, ton 618 is the brightest thing. There is nothing in the known universe that outshines it at peak output from a localized source. If you wanted to identify the single point in space producing the most light per unit time in the observable universe, ton 618 is a strong candidate for that title. It is, in the language of extremes, the maximum expression of brightness the universe has so far managed to concentrate into a single location. And now here is the part that I find genuinely beautiful in a slightly disorienting way. Ton 618 does not matter, not to the cosmic background, not to the argument we have been building tonight. Despite being 10 billion light years away, despite being 1 trillion times brighter than the Milky Way, despite being one of the most energetic sustained processes we have ever identified in the observable universe, ton 618 does not meaningfully perturb the average brightness of the cosmic background skies we have been discussing. The extragalactic background light does include its contribution. Every photon it has ever emitted that has been traveling toward us is technically part of that 11 nanowatt per square meter per steradian aggregate measurement. But so are the contributions of every other quasar, every other galaxy, every other star that has ever existed, all added together across 13.8 billion years of cosmic history. And the result of adding ton 618 to that sum is not a noticeable bump. It is a rounding error. The most extreme brightness in the known universe is so thoroughly diluted by distance, by the expansion of space stretching its photons toward longer wavelengths, and by the sheer cumulative weight of contributions from trillions of other sources, that it does not register as a special hotspot in the background. It is one instrument in an orchestra so large that even its loudest note disappears into the total sound. That is a remarkable thing to realize. We have spent considerable effort tonight building the case that the universe is brighter than it looks, that the background signal environment of every point in space is fuller than your eyes suggest, that darkness is a perceptual artifact rather than a physical condition. And ton 618, the brightest single thing we know of, cannot change that picture in either direction. It cannot make the background meaningfully brighter because the background is already the sum of everything, and its existence does not rescue the concept of darkness in the spaces around it, because those spaces are already full of microwave photons and neutrinos and infrared backgrounds and gravitational waves operating completely independently of what ton 618 is doing. More importantly, and this is the real point, the existence of the brightest object in the universe does not change the darkness of the spaces between it and us, which proves the argument in reverse. If a source 1 trillion times brighter than the Milky Way, located 10 billion light-years away, cannot meaningfully alter the background brightness of the universe, then the universe's brightness does not come from having a few extraordinary sources. It does not come from extremes. It comes from having everything, everywhere, always. It comes from the accumulated, continuous, uninterrupted emission of 13.8 billion years of cosmic activity, none of which has been lost, all of which is still travelling, all of which is still arriving. Ton 618 is spectacular. I want to be clear about that. It is one of the most extreme objects we have ever discovered, and the fact that we can detect something 10 billion light-years away in enough detail to measure its black hole mass is itself an extraordinary achievement of human science. But it is not the reason the universe is bright. It is a single, extraordinary data point in a dataset so large that it cannot move the average. The universe is bright because there is no off switch, no empty channel, no wavelength of silence, no moment in cosmic history where the emission simply stopped and the photons already traveling were somehow recalled. Every photon ever produced is still in the universe, still moving, still contributing to a background that was being built before TON 618 existed, before any quasar existed, before the first star ignited. The background predates the brightest sources. It will outlast them too. When TON 618 eventually exhausts its fuel supply and its accretion disk fades, the cosmic microwave background will still be there, 411 photons per cubic centimeter, as uniform and patient and ancient as it has always been. The brightest thing in the universe is a footnote in the universe's brightness budget. Think about that. And then ask yourself what that implies about every other source you thought was contributing to the darkness by being absent from the places they don't occupy. Darkness was never about the absence of bright things. Darkness was about the limits of the instrument you were using to look for them. Part 22. Remove everything. Let's do one final thought experiment, and I want to be upfront with you. This one is the most generous version of the argument for darkness that I can construct. We are going to give darkness every possible advantage. We are going to clear the board completely and see what's left. Imagine we could somehow remove all the matter in the universe. Not just the visible matter, all of it. Every galaxy, every star, every planet, every moon, every asteroid, every dust grain, every cloud of interstellar gas, every atom of hydrogen floating alone in the space between galaxies. Gone. Now remove the cosmic microwave background photons. All 411 per cubic centimeter. Gone. Remove the neutrinos, the 336 cosmic background particles per cubic centimeter that have been streaming freely since 1 second after the Big Bang. Gone. Remove the extragalactic background light, the infrared background, the X-ray background, the gamma-ray background, the radio background. Clear away every known radiation field at every frequency. Remove the gravitational wave background. Silence the space-time hum of every black hole merger that has ever occurred. Take it all away. You have now constructed the most aggressively empty environment that the human imagination can produce. A region of space with no particles, no photons, no neutrinos, no gravitational waves, no matter of any kind. A true vacuum. The idealized, maximally empty physics textbook definition of nothing. And according to the best current understanding of reality, what you are left with is not nothing. Not even close to nothing, actually. And this is where physics stops being counterintuitive and starts being something closer to philosophically destabilizing. So let's take it slowly. In 1948, a Dutch physicist named Hendrik Casimir was working through the implications of quantum field theory, the framework that describes how particles and forces behave at the smallest scales, when he made a prediction that seemed almost too strange to be taken seriously. He predicted that if you took two uncharged, perfectly flat metallic plates and placed them extremely close together in a true vacuum, with all thermal photons removed, those plates would attract each other. Not because of gravity, the effect is far too strong for that at the scales involved. Not because of static electricity, the plates are uncharged. Not because of any conventional force, because of the structure of the vacuum itself. The reason, Casimir argued, is this. The quantum vacuum is not empty space. Quantum field theory requires that every point in space is permeated by quantum fields, the electron field, the photon field, the quark fields, and others. And these fields are never perfectly at rest. They fluctuate, constantly, unavoidably. The mathematics of quantum mechanics, specifically the Heisenberg uncertainty principle, makes it impossible for any field to sit at exactly zero energy. There is always a minimum residual activity, a ground state buzz that cannot be removed, no matter how cold or how empty the environment gets. And this activity manifests as virtual particle pairs, photon pairs, electron-positron pairs, and other combinations that flicker into existence and annihilate almost instantaneously, too briefly to be directly detected but long enough to have real, measurable physical effects. Now, when you place two metal plates very close together, you change the geometry of the vacuum between them. The plates act as boundary conditions on the photon field. They restrict which wavelengths of virtual photons can exist in the gap between them, because only photons with wavelengths that fit an integer number of times into the gap are permitted. Outside the plates, no such restriction exists. The full spectrum of vacuum fluctuations operates freely. Inside the gap, a subset is forbidden. This creates a pressure difference. The outside pushes in slightly more than the inside pushes out. The plates are attracted to each other by the activity of the vacuum in the space around them. Casimir predicted this in 1948. It was first experimentally confirmed in 1997 by physicist Steve Lamoureux, who measured the Casimir force directly and found it matched the theoretical prediction to within 15%. Subsequent experiments have refined that agreement to within a few percent. The Casimir effect is not a theoretical curiosity. It is a measured, repeatable, engineering-relevant, physical phenomenon. It is real enough that nanotechnology engineers have to account for it when designing components at very small scales, because the force becomes significant when surfaces are separated by distances measured in nanometers. And the Casimir effect is not the only evidence that the vacuum is active. The Lamb shift is another. In 1947, physicist Willis Lamb measured a tiny but precise discrepancy in the energy levels of the hydrogen atom, specifically between two states called the 2s1/2 and 2p1/2 states, which should have identical energies according to the Dirac equation but do not. The discrepancy, now called the Lamb shift, is caused by the interaction of the hydrogen atom's electron with the fluctuating quantum vacuum. The electron is constantly being buffeted by virtual photons popping in and out of existence around it, and this buffeting slightly shifts its energy levels in a way that is precisely calculable using quantum electrodynamics and precisely measurable in the laboratory. The agreement between theory and experiment for the Lamb shift is one of the most accurate confirmations of any physical theory ever achieved, accurate to better than 1 part in a billion in some measurements. These are not rounding errors. These are not philosophical abstractions. These are hard, quantitative, experimentally confirmed consequences of the fact that the vacuum has non-zero energy. The vacuum is not a passive stage on which physics happens. The vacuum is a participant. It has structure, it has energy, it fluctuates, it pushes, it shifts the energy levels of atoms. It is, in the most literal physical sense, active. Now take that fact and scale it up to cosmology. Einstein's general relativity equations contain a term called the cosmological constant, usually represented by the Greek letter lambda. Einstein originally introduced it for the wrong reasons. He thought it was needed to produce a static universe, and he later called it his greatest blunder when Hubble's observations showed the universe was expanding. But the cosmological constant did not go away. It came back in 1998 when 2 independent teams studying distant supernovae discovered that the universe's expansion is not slowing down due to gravity as expected. It is accelerating. Galaxies are flying apart from each other faster and faster over time, driven by something that acts like a repulsive energy density permeating all of space uniformly. That something is what we now call dark energy, and in the framework of general relativity, it is represented by exactly the kind of non-zero vacuum energy density that quantum field theory predicts. We do not know what dark energy fundamentally is. The honest answer is that it is one of the deepest unsolved problems in all of physics. In fact, the discrepancy between the vacuum energy density that quantum field theory naively predicts and the value that cosmological observations actually measure is famously described as the worst prediction in the history of physics, off by a factor of somewhere around 10 to the 120. That discrepancy is itself one of the great mysteries of modern science. But the key point for our argument is this: whatever dark energy is, it is real, it is non-zero, and it is a property of space itself rather than of any matter contained within it. Every cubic meter of space, including our maximally empty, matter-free, radiation-free, particle-free thought experiment vacuum, has a non-zero energy density. Space is not nothing. Space has never been nothing. Space cannot be nothing because the physics of the vacuum forbids it. So let's close the loop. We started this thought experiment by giving darkness every conceivable advantage. We removed all matter, all radiation, all particles, all known background fields. We built the most empty environment the imagination can construct. And we found that even there, especially there, the physics of reality does not permit silence. The quantum fields are still fluctuating. Virtual particles are still appearing and annihilating. The cosmological constant is still non-zero. The vacuum energy is still present. Empty space, in the most fundamental sense that physics can currently address, is not empty. It is a seething, active, energetic medium that happens to contain no persistent particles at this particular moment, but which is never at rest, never at zero, never truly nothing. The last refuge of darkness was the vacuum itself. The idea that even if photons and neutrinos and gravitational waves filled every corner of the real universe, at least the substrate, the canvas, the medium, the thing that space actually is at its most fundamental, was passively empty and dark. That refuge does not hold. The canvas is not blank. It is painted with quantum activity at every point, continuously, without exception. There is nowhere to go. No thought experiment empty enough, no idealization clean enough, no abstraction pure enough to produce the condition of true darkness. Physics does not offer it. The universe, at every scale from the cosmic to the quantum, from the largest structures to the smallest possible volumes, from the most matter-dense environments to the most completely evacuated theoretical vacuum, is active. It is energetic. It is, in the only sense that physics can ultimately verify, inescapably bright. Reality has no off position. It never did. Part 23. The Final Synthesis. So what have we actually established tonight? Let's be precise about this, because the argument has accumulated a lot of moving parts over the course of this video, and I think it's worth slowing down for a moment and laying them all out in one place. Not as a list of interesting facts, as a single coherent picture. Because when you see it assembled, the conclusion is harder to dismiss than any individual piece of it. We established first that human vision is biologically constrained to a single, narrow band of the electromagnetic spectrum, roughly 380 to 700 nanometers. That range represents a vanishingly thin slice of the total electromagnetic spectrum, which spans from radio waves hundreds of meters long all the way down to gamma rays, smaller than an atomic nucleus. If you laid the entire electromagnetic spectrum across a football field, the portion your eyes can detect would be thinner than a human hair. Everything outside that hair-thin band is invisible to you, and the universe, as it turns out, broadcasts heavily, constantly, and in some cases uniformly in every part of the range you cannot see. Your eyes are not a window onto the universe. They are a keyhole. We established that the cosmic microwave background, the afterglow of the Big Bang itself, released when the universe was 380,000 years old and the fog of the primordial plasma finally cleared enough for light to travel freely, fills the universe with 411 photons per cubic centimeter at a temperature of 2.725 Kelvin. Those photons arrive from every direction simultaneously at every point in space. Not most points, every point, the center of the Boötes Void. The space between your atoms, the interior of a mountain. The microwave sky is not a scattering of sources on a dark background. It is a uniformly glowing sphere in every direction simultaneously, and you are inside it, and you always have been, and you were never built to know it. We established that the extragalactic background light represents the cumulative optical and near-infrared emission of every star in every galaxy across the entire history of cosmic time. 13.8 billion years of stellar activity, all of it still traveling, all of it still arriving. And we established that this background is measurably brighter than can be accounted for by adding up all the galaxies we have catalogued. The universe, even in the one frequency range our eyes can technically access, is producing more light than our inventories predict. There is more optical brightness out there than we know how to explain. The universe is not just bright in the channels you can't see, it is brighter than expected even in the one channel you can. We established that the cosmic infrared background represents roughly half of all the starlight ever produced, specifically the half that was absorbed by dust before it could reach you in its original form, and re-emitted at longer wavelengths in the far infrared. That is not a small correction. That is half the energy budget of all stellar emission across cosmic history, redirected into a channel your eyes cannot access, still present, still traveling, still arriving at every surface everywhere. The universe has two parallel light systems operating simultaneously: direct starlight and reprocessed starlight. Both are omnidirectional, both are constant. You have never been able to see either of them fully. We established that X-ray, gamma-ray, and radio backgrounds exist at every point in the sky simultaneously, produced by the most energetic processes the universe has ever generated, accreting black holes, gamma-ray bursts, relativistic jets, neutron star mergers, accumulated across billions of years of cosmic history and arriving continuously from all directions. We established that the radio background alone is roughly 5 times brighter than theoretical models predict, which means that even our best current accounting of the universe's emission systematically underestimates its actual brightness. Every time we have improved our instruments or pointed them at a new frequency, we have found more signal than we expected. Not less, more, always more. We established that the cosmic neutrino background, 336 particles per cubic centimeter, every cubic centimeter, everywhere, produced when the universe was exactly 1 second old, permeates every point in space, with particles that interact so weakly with matter that they pass through the entire Earth as though it is not there. Billions of them pass through every square centimeter of your body, every second. They have been doing this since before the Earth existed. They are the oldest detectable matter in the universe, carrying information about a cosmos younger than any human concept of time. And they are inside you right now in quantities that would be alarming if you could feel them. We established that the stochastic gravitational wave background, confirmed by the nanograv collaboration in 2023, represents a constant, low-level distortion of space-time geometry itself, produced by the accumulated gravitational radiation of supermassive black hole mergers distributed across the entire observable universe across cosmic history. Not a single event, a background. A continuous hum of space-time deformation arriving from every direction simultaneously, physically altering the geometry of the space your body occupies at every moment, at a level too small to feel, but not too small to measure. We established that even on Earth, in the optical band, the darkest possible sky is not optically zero. Airglow, the chemiluminescent emission of the upper atmosphere, contributes roughly as much light to the night sky as all the visible stars combined, even at the most remote dark sky sites on the planet. We checked deep space within the solar system and found the cosmic background signals unchanged. We checked the lunar far side, the most isolated surface environment any human or probe has ever visited, and found the CMB present, the neutrino background present, cosmic rays arriving unimpeded by any atmosphere. And we checked the center of the Boötes Void, the emptiest known region of the observable universe, 330 million light-years across, containing perhaps 3% of the galaxies statistical models predict, and found that in every non-optical channel, the signal environment was indistinguishable from what it is anywhere else in the universe. The void was not quieter, the void was not darker. The void was the same, because the cosmic background signals do not depend on where the galaxies are. They live in the structure of space itself. And finally, we established that even removing all matter from a region of space, constructing the most aggressively empty environment the imagination can produce, does not produce true darkness. Because quantum vacuum fluctuations are real and measurable, the Casimir effect is experimentally confirmed. The Lamb shift is one of the most precisely verified predictions in the history of physics, and the cosmological constant requires the vacuum itself to carry a non-zero energy density. The canvas is not blank, the substrate is not passive, the vacuum is not nothing, it never was. When you lay all of that out in sequence, what you are looking at is not a collection of individually interesting scientific discoveries. What you are looking at is a pattern, the same pattern at every scale, at every frequency, in every location, through every physical channel that exists. And the pattern is this: the universe is inescapably active. It has been active since 1 second after the Big Bang. It has never paused. It has never gone quiet. It has never turned off a channel, emptied a frequency, silenced a mode. The universe does not have an off position. It does not appear to be capable of developing one. Darkness, the intuitive, felt, bone-deep, seemingly obvious darkness of the night sky that you have been experiencing your entire life, is not a feature of the universe. It is a feature of you. It is what the universe looks like to a biological detector that was assembled by evolution for the specific, narrow, survival-oriented purpose of navigating a planetary surface during one phase of a 24-hour light cycle. Your eyes are extraordinary. They are among the most sophisticated light detectors that biology has ever produced. They can detect a single photon under ideal conditions. They can resolve features separated by less than an arc minute across a wide field of view. They are astonishing instruments. They are also instruments tuned to one specific job, in one specific environment, optimized for one specific slice of reality. Outside that slice, they report nothing. And the universe, being indifferent to what your eyes were built for, broadcasts the overwhelming majority of its signal outside that slice. The universe is not dark. It has never been dark. It cannot be dark, not in any physically meaningful sense, because producing a true absence of signal at all frequencies simultaneously would require violating quantum mechanics and thermodynamics at the same time. The universe, as currently constituted, is physically incapable of silence. The conditions for darkness do not exist within the laws of physics as we understand them. Darkness is not out there. It has never been out there. It is in here, in the narrow bandwidth of human perception, in the biological legacy of a species that spent millions of years navigating by the light of a single nearby star, in the evolutionary accident that gave you eyes sensitive to a frequency range where the universe happens to broadcast less uniformly than in any other band. Your darkness is not the cosmos's darkness. The cosmos has no darkness to offer you. It never did. You just didn't have the right instrument to know that until now. Part 24. The Quiet Return. Come back now. Come back to the opening image. A clear night, no moon, far from the city. You tilt your head back, and you see a field of scattered white points against a field of perfect black, stars, and between them, nothing, black. The deep, quiet, enormous nothing of outer space. Everything looks the same. The sky is identical to the one we started with. Nothing visible has changed. The same stars, the same apparent blackness between them, the same feeling of standing at the edge of something incomprehensibly large and quiet. But you know now what that image actually contains. Right now, as you stand on that ridge, or in that field, or wherever you found your piece of dark sky, approximately 25 million cosmic microwave background photons are passing through your body every second. The oldest light in the universe, light produced when the universe was 380,000 years old, before any star had formed, before any planet existed, light that has been traveling for 13.4 billion years, is arriving at your skin from every direction simultaneously, not metaphorically, physically, measurably. If you had microwave-sensitive eyes, the sky would be a uniform glowing dome with no dark patches anywhere. Right now, several billion cosmic neutrinos are passing through every square centimeter of your body every second. Not through the air around you, through you. Through the atoms that make you up, through the nucleus of every cell, through every molecule of every protein and every nucleotide of every strand of DNA. Particles produced 1 second after the Big Bang, carrying information about a universe younger than any human concept of time, passing through your body as though you're not there. Because to them, you're not. Right now, space-time is vibrating. The stochastic gravitational wave background is gently, imperceptibly distorting the geometry of the space your body occupies. You are being squeezed and stretched by the gravitational echoes of black hole collisions so massive and so distant that the effect on any single meter of space is smaller than a proton's diameter. But it's happening. The universe's most violent history is writing itself onto your geometry in the smallest possible handwriting. Right now, the extragalactic background light, the cumulative optical glow of every star that has ever burned, in every galaxy that has ever existed, across 13.8 billion years of stellar activity, is arriving at your retina from every direction. It's too faint to trigger your visual system, too diffuse to focus into an image, too uniform to produce a contrast signal that your brain can interpret. But it's there. Every photon from the first generation of stars, from galaxies long dead, from supernovae that occurred before our sun was born, all of it is still travelling, and some of it is arriving at your eye right now, and failing, just barely, to cross the threshold of your perception. You are, at this moment, the most information-dense point in the universe, in the most important possible sense. You are a conscious system inside a universe that is broadcasting everything it has ever known in every direction at once. And you are beginning to understand that. The universe has been talking to you since before you were born, in every frequency it can produce, at full volume, in every channel, simultaneously. The silence you thought you heard was you. The darkness you thought you saw was your eye's bandwidth limit. The emptiness you assumed was out there was never out there. What is out there? What has always been out there? What fills the Boötes Void and the centers of galaxy clusters and the space between your atoms with equal density is the accumulated memory of everything that has ever happened, still traveling, still arriving, still writing itself onto every surface and every particle and every unit of space-time. Every night of your life that you have looked up at the dark sky and felt the smallness of being a single biological organism on a single rocky planet, in a single ordinary galaxy, in a cosmos of apparently infinite emptiness, that feeling was built on a misunderstanding. The cosmos is not empty, it is full. It is so thoroughly, completely, inescapably full that the single most technically challenging task in modern cosmology is not finding signal, but separating one signal from the dozens of others arriving simultaneously. The universe is not a dark room with a few bright specks in it. It is a broadcast medium operating at full capacity in every channel, and you have been swimming in it, permeated by it, constituted from it, your entire existence. The sky is not dark, you are just blind to how bright it always was. And now, standing on that ridge, the same stars in the same black sky above you, you know what you can't see. You know about the microwave dome enclosing you in ancient light. You know about the neutrino rain falling through your body from 1 second after creation. You know about the gravitational hum in the geometry of the space you occupy. You know that the apparent black background of the night sky is a narrow bandwidth illusion, a perceptual accident of evolution, a product of eyes that were never designed to see the universe as it actually is. And if that knowledge produces in you not fear, but something quieter, the sustained, patient, slightly vertiginous feeling of standing in a place far stranger and more alive than you were taught, then that's exactly the right response. Because that is the accurate response. The universe is strange in exactly this way. It is alive with signal in exactly this quantity. And you are inside it, permeable to it, constituted from it, at every moment of every day. Go outside tonight. Look up. Feel it. The sky is not dark. You are blind. And now, for the first time, you know what you're missing.